Thank you.
So please, brother, see this file. I am just I'm just showing one file that is nothing but your syllabus for Physics 1. So we are going to cover the syllabus based on this phasing schedule. Understand? So first week we will cover the first chapter, the second week second chapters. Likewise, every week we will cover a chapter. So please, inshallah, I will put all this information in your blackboard, inshallah, by today or tomorrow, inshallah. So better you take a copy, and then our class session will be based on the syllabus. Clear?
Clear.
Yes, teacher.
Okay,
Yes.
thank you. So now we just, I'm going to turn on my slides for Physics 1, first chapter. Is it visible for you?
Yes.
Yes, teacher. Yes, we can see.
Okay, okay. This is our grading scheme. General Physics 1, our physics code will be SEI 152. So how we just make a grading scheme? For the laboratory, you will get 30 marks. Understand? And then quiz 1 5 marks, quiz 2 5 marks, midterm 20 marks, assignment 10 marks. Brother, actually this assignment, after the quiz 1 we will give one assignment which carries 10 marks, and after the quiz 2 we will give one more assignment which carries 10 marks, and then we will take an average. Understand? So this assignment mark will be entered in week number 13 or 14 in your SIS, and then your final theory exam will be 30 marks. So totally 70 marks comes from your theory part, and then 30 marks comes from your lab part. So please try to work hard, try to get full marks, try to get A+. Understand?
Understand.
And
Teacher,
then, yes, brother.
do we need to book or the slides?
Actually, brother, a book have more information. Better you just buy the book. That will be helpful not only for the Physics 1 and Physics 2. It will be helpful for the mechanical as well as civil. If you are from mechanical and civil student, that will be quite helpful for understanding the basic concept in physics. Clear?
Clear.
Yes.
Okay.
Yes,
But we as a teacher, we prepared the slides based on your syllabus only. So it is my suggestion, just go through the slides. If you want to know additional information, go and refer your book. Understand? Because the slides are prepared based on your book only.
If I stay from just slides,
It's enough. It's enough. But if you want to get more info,
take A+?
yes, of course you can.
Oh, thank you.
But for additional information, if you like to know more information from the Physics 1, you can just go and refer something from the book. Understand?
Understand.
Okay. Now, if you just see this slide, the theory part, you will get 70 marks. Am I right? So that 70 marks, the quiz 1 will be conducted in 4th week, midterm will be in your 8th week, quiz 2 will be in 12th week, and the final theory exam, sometimes it may be vary according to our calendar. For the time being, I just put 16th and 17th week. So your lab exam exactly before a week of your final theory exam. The lab final exam will be exactly before a week of your final exam. Clear?
Yes, teacher.
Clear.
Clear.
Yes,
Okay.
clear.
And this book we will follow for this semester, Principle of Physics, student edition. And also it's a 10th edition. The title of the book is Principle of Physics by Walker, Halliday and Resnick. So better have a copy. That will be quite helpful in future, inshallah.
Inshallah.
Okay, let's start our topic. The today lecture is from chapter 1, measurements, and this topic is very easy, and we already missed our class session on Sunday because the blackboard was not updated on Sunday. That's what we lose two classes on Sunday. But don't worry, inshallah, if I can't able to cover the syllabus by this period, I plan to open one makeup session either today night or tomorrow night. Which time will be better for you?
I
Tom-
don't
What?
know actually.
Because today we have only one class. At least I have to finish my chapter by this week. This one period is not enough for. If one period is not enough for this classes, so I like to open one makeup classroom either by today night or tomorrow night. Which time will be convenient for all the students?
For
Tomorrow
today,
night.
Wednesday,
Tomorrow night.
some students, Yeah, I have
Okay.
calculus 2 at
Okay.
night. So
Night means no. I'm asking. So is it possible tomorrow?
Yes,
Yes,
tomorrow.
it's possible, but
yes, it's okay.
I didn't know about the other students, if they have class or not.
I will just open after the Isha prayer. That will be quite good.
Teacher,
At Elisha?
in the
Okay.
afternoon, I think all we don't have a class today. In the afternoon.
Today what time?
شباب احد عنده لاب اليوم.
لا
بس
لا
عندنا كالك
لا عندي لاب بكره.
عصر العشاء.
Brother. Okay. Okay. Just a minute. Please listen here. Actually, period number 1 and 2, I finished this lecture for another section. I hope that video is already available on the Blackboard. Shall I give the link for that?
We don't know.
Which one you need? You want the class or you want video?
Afternoon.
Today afternoon I have the lab class.
Tonight, teacher, tonight.
Okay, tell me the time, brother. If you tell me the time only, then I can. Is it possible from 9 to 9:50 night time?
Or
Today?
5,
One
5 to
period?
5:50.
Okay.
One period is enough. One period or more than I will just open for 1.5 hour.
1 hour, huh?
1 hour and 50
Okay.
minutes. Just if
Okay.
needed. If needed.
Oh,
wait خلاص يا نخليها الساعة 5 من 5 إلى 5
خمسة.
عشان
عندي كلاس
9 في ناس
كالك.
متى عندك كلاس الكالك؟
الساعة 9
كالك 2 عندنا الساعة
يا عيال بعد
Brother.
المغرب الساعة 7 كويس.
Excuse me,
يا عيال
brother.
واحد عشان نفهم.
Excuse me. Please listen here. I am just going to open one makeup classroom from time 9 to 10:30 night time. Is it possible?
7
What about today, teacher?
Today what time? You tell me the time, brother. If the time is okay, then I will come.
Okay.
الساعة 7 عيال كويسة. الساعة 7 كويسة.
انا اشوف الظهر
7
كويس.
تمام.
7 to 7 to
7
7 عادي.
Yeah. لا كلاس
7 to 9.
Okay.
7 to 9. Okay.
اوكي.
Okay, that's
Yeah.
good. So
Yes,
7 to
okay,
7
okay.
to 9, inshallah, I will open the session. Even if you miss the class, you can get the video from the Blackboard. Understand? Okay, let's start.
Okay.
So today topic is measurements. In physics, the measurement plays. Yes.
Attendance tonight.
No.
There
Don't
will
worry
be
about
a-
that attendance. Don't worry about that attendance. That
Okay.
attendance was not countable.
Okay.
Forget about it, because I want to finish the lecture. That's what I open in a makeup classroom. 7 o'clock to 9 o'clock. Okay.
Okay. Thank you,
Okay,
teacher.
good. Okay, brother. So, okay, let's start. The topic of today lecture is measurements. The content today, what we are going to discuss based on units. We are going to discuss the basic units, which is nothing but the unit for length, unit for mass, and unit for time. What is the unit for length?
The meter and
Centimeter.
Unit for length is meter or centimeter or feet. The unit for mass is kilogram, gram, or pound or pounds. The unit for time is only second. Okay.
yes, second.
And then we are going to learn how to convert the unit from one unit to another unit. For example, if I ask you to convert from 1 centimeter to meter, how you have to do? If I ask you to convert 1 kilogram to gram, so there are some methods and there are some constant value to convert the unit from one range to another range. One range is nothing but one unit to another unit. Understand? So these are all the contents today we are going to discuss from this class. In the first slide, I am just giving what is physics. So what is physics? The physics is nothing but it's a study of matter and its energy and the interaction between them. In other words, you can say everything. Whatever the things are surrounding us is related with physics. So in that, particularly, we are just focusing on metrology. What is the meaning for metrology? The metrology is nothing but it is the study of the science of measurements, embracing both experimental and theoretical. So in this scientific world, if you want to measure anything, you can just measure accurately based on the scientific measurements. So metrology is related with the measurements based on the scientific technology. So these things are exactly designed by the International Bureau of Weights and Measures, which gives a clear picture about how to measure each and every thing. Now, if you just see the concept of measurements, if you want to measure anything, you need a quantitative data, a collection of data. Collection of data is a record first. After you get the data, you have to compare with the standard unit. For example, I gave an example in this slide. You can just read the length of the piece of a string can be measured by comparing the string against the meter stick. For example, you take a string or you take a wire. You don't know what is its exact length. So how you can measure? If you have a meter scale, when you just use the meter scale, you can easily measure its length. So here the unknown quantity is nothing but the length of the piece of the wire, what you have in your hand. You are just comparing that length with a meter scale. If you have a meter scale of 1 meter scale or 2 meter scale, you can just compare with a standard unit and finally you will get an answer. In our day-to-day life, you can just see this picture. We are just having all this work in our day-to-day life. You go to the market, you buy a fruits or vegetables. So if you buy a fruit or vegetable, first of all, you have to measure its weight or mass. Am I right or not? And also, if you want to buy any water or a milk or any juices, you have to first find out what is the volume capacity of the can or volume capacity of the tank. So whatever the things you want to buy in terms of liquid nature, you have to consider what type of jar you are going to take, what type of bottle you are going to take, and each and every bottle, each and every container has its own volume. And then you can easily measure. In our day-to-day life, we measure the length, and in our day-to-day life, we measure the temperature also. Suppose if you want to measure what is the temperature of the room, what is the temperature outside, you can just measure its temperature accurately with the help of the scientific invention. We have a thermometer. When you just use the thermometer, you can find what is your body temperature. And also in your home, you are using the AC. So when you just turn on the AC, you can particularly fix the particular temperature, and finally you will reach the temperature. So you can just see all this picture, and these all pictures are from our day-to-day life. So everything is related by some measurements. Understand?
Yeah.
Do you hear? It's clear?
Yes, yes.
Yeah, but it's too fast.
Too fast? Okay, I will just reduce my speed.
Thank you, teacher.
Okay. Now, if you just see this slide, you are making a measurements when you are checking your weight, read your watch, take your temperature, check your height. Brother, you should, first of all, you have to remember one thing. In physics, if you just, for example, I am asking you a question, what is your height? What should be your answer? If I'm asking you a question, what is your height? What answer you gave for me?
With
1.6 meter.
1.6 meter. Am I right? Say my height is 1.6. What it means? It's nothing. Am I right? So
it doesn't mean anything.
Actually, in physics, if you just say the number, it is meaningless. So if you want to say anything, you have to connect that data with a unit. That's what we are saying. It is a measure. That's what I said. It is a measurement of quantitative data. You have some quantity, and with the help of that quantity, you have to attach some unit. For example, I am asking you the question, what is your height? You have to say, my height is 177 centimeter. Without the word centimeter, it is meaningless. And I'm asking you the question, what is the temperature of the room? You have to say the temperature of the room is 20 degrees Celsius. Suppose I am asking you the question, what is the time right now? You have to say, right now the time is 9:35 a.m. Clear? So the unit plays an important role in the measurement, especially the measurement needs the information about the unit. Without unit, it is totally meaningless. Now, the System International, they design the type of quantities, which is nothing but the fundamental quantities as well as the derived quantities. If you just see this table in the bottom of the slides, I just gave two tables. You can see this is my fundamental quantity, this is my derived quantity. What you understand from this fundamental quantity and derived quantity? Everything comes from SI unit. So the fundamental quantities, you have 7 datas. What are they? Mass, length, time, current, temperature, amount of the substance, and luminous intensity. So these 7 fundamental quantities are very, very important for studying the concept of fundamental data. With the help of these fundamental quantities, you can derive many other quantities. For example, volume. What is the unit for volume? The unit for volume is meter cube. So what is the formula for volume? The volume for the formula is length multiplied by width multiplied by its height. Am I right? So what is the unit for length? The unit for length is meter. The unit for width is meter. The unit for height is meter. So what is the unit? My unit is meter cube. So where you got this? You got this information from the fundamental quantity. So with the help of the fundamental quantity, you can derive many derived quantities. For example, density. What is the formula for density? The formula for density is rho, which is equal to mass over volume. What is the unit for mass? The unit for mass is kilogram, and the unit for volume is meter cube. That's what it is written here, kilogram per meter cube. What is the unit for speed? The unit for speed is distance over time. What is the unit for distance? The unit for distance is meter, and the unit for time is second. So that's what we written here. We written as meter per second. So with the help of these 7 fundamental quantities, we have 7 numbers. You can see here 1, 2, 3, 4, 5, 6, 7 fundamental quantities. You can use the 7 fundamental quantities for getting its derived quantities. You can use this. Clear?
Yes.
Yes,
Yes.
okay.
But
Yeah.
I want to ask you about something.
Yes,
The
brother.
luminous
Luminous intensity is
intensity.
based on the light, brother. Candela. Actually, its unit is the name is nothing but candela. The symbol what we are using is CD. It is related with the studying of lights. So that is not related for our topic because we are studying the basic information from physics. So luminous intensity is related with the light. Clear? Now you can just see here, brother. Yes, brother.
Can you click in the hide and the below the page? There's a
This one,
bar.
this one.
Yeah, this one.
Yes.
Can you click?
Okay,
Yeah, thank
okay.
you.
Is it clear now?
Yeah, thank you.
Yes.
Okay, okay. Now you can see here what are the characteristics of unit, because I told you in physics without unit it is meaningless. So if you are using the unit, what are the characteristic features of the unit? You can see it is well defined. What is the meaning for well defined? Just before I told you, if I ask you the height, you said 177 centimeter. That means it is perfectly defined number along with its unit, and also it's a suitable figure. Suitable for size means it will not vary because the suitable size and the variable is exactly related with each other. So, and it is reproducible. What is the meaning for reproducible? You can convert this 177 centimeter to meter, and also meter to kilometer. So it is a reproducible unit. The unit can be reproducible. Invariable, it will not change. My 177 centimeter height is not changeable. That's what we are just saying. It is an invariable, and it is indestructible. It will not change. For example, my 177 centimeter height will not be destructible. Destructible means you can just totally destruct. It is not possible. Finally, the most important thing, it is universally acceptable, internationally acceptable. So when you are about to use this unit, these are all the 6 points which will be very, very important when you are using the unit with a number. So it is well defined, which is suitable size, reproducible, invariable, indestructible, and internationally acceptable. Brother, we have 3 types of measurements. The first one is MKS system. Have you ever heard about this? We have 3 system of measurements: MKS system, CGS system, and FPS system. Have you ever heard about these things, brother? It is not FR, FPS.
No.
No,
Okay.
No, we don't.
These 2 systems are given by the French people. Who gave these things?
French people.
The French people, they just use this measurement, but the last one is by British. So here the M stands for meter, K stands for kilogram, and S stands for time. Here the C stands for centimeter, G stands for gram, and S stands for time. Yeah, time unit is nothing but the second. And F stands for foot or feet, P stands for pounds, and S stands for time. So in some countries they are following this method, but what we are using, we are always using the system of MKS. So when you are about to solve any problems, you have to give the answer either in terms of meter, either in terms of kilogram, either in terms of seconds. You should be very, very careful, brother, because in every chapters we are going to solve 5 problems. When you are about to solve these 5 problems, you should be very, very careful. Finally, you have to give the answer. If the answer is related with centimeter, you have to convert that centimeter to meter. Final answer must be in meter. If you have any answer in terms of grams, finally you have to give the answer in terms of kilogram. So you should be very, very careful, because we are just following this MKS system. Now, when we just come for the basic unit, because our content says basic, we are going to get some idea about basic unit. The basic unit about the length, mass, as well as time. What is the unit for length? Meter. What is the unit for mass? Kilogram. What is the unit for time? Second. Which is nothing but, you can see which system we are using.
The MKS.
MKS system we are using. Clear?
Yes.
Always we will use the MKS system. You should be very, very careful. Now, in physics, when you are about to write a bigger number, you have to use that number, you have to write that number in terms of power of tens. For example, you can see the table, 2 tables are here. The first table is this, the second table is this. And sometimes when you have a bigger number, you can see this, how bigger it is. 356000000. Am I right? How you can write this number? You have to write this number in terms of power of tens. That means you have to compress the number in terms of power of 10. Likewise, you can see the table. We just gave many information. Out of this, these 3 are very, very important. What are they? 10 to the power of 9, 10 to the power of 6, 10 to the power of 3. So what 10 to the power of 9 stands for? It stands for giga. 10 to the power of 6 stands for mega. 10 to the power of 3 stands for kilo. So these 3 are very, very important. Always please keep this information in your mind. Likewise, in this table, this 10 to the power of minus 2, 10 to the power of minus 3, 10 to the power of minus 6, 10 to the power of minus 9, and 10 to the power of minus 2. It's very, very important. While you solve the question, some informations are given like this. So if you have the word centi, it's related with 10 to the power of minus 2. If you have milli, it's related with 10 to the power of minus 3. Micro means 10 to the power of minus 6. Nano means 10 to the power of minus 9. Pico means 10 to the power of minus 2, minus 12. Suppose I am asking 6 micrometer. How you can write? 6 multiplied by 10 to the power of minus 6 meter. 6 nanometer. How you can write? 6 multiplied by 10 to the power of minus 9 meter. So this micro stands for 10 to the power of minus 6. This nano, small n, stands for 10 to the power of minus 9. So brother, in this table, keep these 3 and keep these 5 always in your mind. So totally 3 plus 5, 8 informations are very, very important while you solve the problem. Understand?
Yes, we are. Thank you.
Okay.
Yes, teacher.
Now, what is the definition of meter? So, brother, there are many definitions for meter based on century to century, because in olden days they are using some different definition for the term meter. Nowadays they are just using the concept of the scientific technology, and finally they just come for the perfect definition for the meter. What is given in the definition of meter? You can just read: a meter is the length of a path traveled by light in a vacuum during the time interval of 1/2 2.9 multiplied by 10 to the power of 8 of a section. What is the meaning for, what is this, brother? Have you ever know about this number? What is this number?
I don't know.
This number is nothing but the speed of the speed of
Light.
light. Speed of the light is nothing but 2.9 multiplied by 10 to the power of 8 meter per second. So, brother, what is given here? For example, you can just see how they just give the definition. They just give the definition for meter based on the light travel in 1 meter. For example, let's define 1 meter distance with respect to light. Before defining its length, we should know what distance a light travels in 1 second in a vacuum. That is very, very important. In 1 second, how much distance the light can travel? How much distance it can travel? It can travel 22.9 multiplied by 10 to the power of 8 meter. It can travel. So if you want to find the particular time, you can just take a reciprocal. If you take reciprocal of this 2.9 multiplied by 10 to the power of 8, that will give you the exact time of the travel by the light in the vacuum. Clear? Actually, it is a bar made up of platinum and iridium, and they kept at constant temperature. And this rod, the diagram which is shown in the slide, this rod right now, it is in Physical Measurement Laboratory, US National Institute of Standard and Technology. If you want to know these things, brother, go to the YouTube, and then you can just type the platinum iridium rod at Physical Measurement Laboratory. If you just type like this, you can just see how they are just protecting this rod in the museum. Actually, it is a laboratory, but they consider it as a museum. It's a very valuable metal. That's what they protected at constant temperature. Why they protected at constant temperature? What's the reason?
It's viable.
Huh? Why they kept this rod at a constant temperature? What's the reason?
Maybe because the material, platinum, iridium.
To keep it the steel.
No, brother. Actually, when you maintain the metal and at constant temperature, you will avoid the rust formation. If you kept any metal subject to the temperature, what will happen? Atmosphere, there are some moisture will be there. It will make rust on the metal. You can put an iron rod outside. What will happen? After 2 or 3 days, you can find some rust. So this is a platinum, right. Because this is a metal. All metals will be subject for the corrosion. In chemistry, you already studied the concept of corrosion. Am I right?
Yes.
So this is a metal. That's what you can just go to the YouTube and then please type this. You will see how they protect this metal very carefully in the laboratory. Clear? Likewise, the definition for the kilogram, it's also kept in the International Bureau of Weight at Sèvres at near Paris. You can see this picture. It's a prototype cylinder of platinum iridium alloy, and which will be protected by the glass jar. Again, the same thing. They will just protect this prototype of platinum iridium alloy at constant temperature, because if you subject this metal under any temperature, what will happen? A rust will form, and when the rust will form, its kilogram will change, its mass will change. So that's what they protect this metal very carefully. Clear? Likewise, the definition of the second will be given based on the cesium atom. Now, if you want to give the answer in another way, in a day, how many hours we have, brother? In a day, how many hours we have?
24.
Okay, 24 hours we have. In 1 hour, how many minutes we have?
60
minutes we have. In 1 minute, how many seconds we have?
60
seconds here. So totally how many seconds in a day? 24 multiplied by 60 multiplied by 60. So what will be the number? How many seconds we have in a day? 86400. 86400 second we have in a day.
68 and 400.
24 hours in a day, 60 minutes for 1 minute is equal to, sorry, 1 hour which is equal to 60 minutes. 1 minute have 60 seconds. When you multiply all these things, you will get this number. Clear? Now, how they give the definition for the second? Based on the cesium atom. What they did? if you just want to know the clear picture about the cesium atom, they are using the atomic clocks. What is the advantage of the atomic clock? The atomic clock gives you the very precise time, because nowadays we are using many different brands of watches. Each and every watches will have some error answer, right or not? Each and every watch gives you some different time. At least some small error will be there. But if you are using the atomic clock, it will give a precise time measurements. So here they are using the cesium-133 atom. You can see the atom. There are many orbits. You can see the outermost orbit. This is our outermost orbit. In the outermost orbit, you have how many electrons? How many electrons you have in the outermost orbit?
Only one.
Only one electron. That
Only
means
one.
it is called as valence electron. What is the meaning for valence electron, brother? Have you ever heard
What
about this
do
word
we-
valence?
No.
No,
Valence,
Valence?
valence electron?
no, but I believe it's the electron that the atom will lose to become stable.
Yeah, brother, the atom is stable, but now I am asking the question about only one electron. If you have one electrons on the outermost orbit, that electron is called as valence electron. Understand? And this electron is very, very responsible for many reactions. Now, these atoms, this electron will vibrate and it will be oscillate. How many times it will be oscillate, brother? How many times it is oscillating? You can see the number. 919263177 times oscillation. That means it will form a wave nature. One complete wave will be like this. One complete wave will be like this. So time to complete one wave is called as 1 period. Time to complete one wave is called as 1 period. Now you can see this atom. How many periods it will be producing by vibration? 919263177 oscillation. This electron will make, and this oscillation will be counted as 1 second. Within 1 second, how many oscillation it will be doing? 919263177 times oscillation. So this much a period it will be producing, and based on that it will be counted as 1 second. Clear? So after the science and technology develops, they are just predicting all the information very precisely. That's what atomic clocks will be used for, getting a very precise time measurements. Also in a day we have 24 hours. When you just count these 24 hours with the 60 minutes multiplied by 60 seconds, we have 86,400 seconds we have in a day. If you want to find a definition for 1 second, then you have to use the concept of the cesium-133 atom. Understand?
Doctor, what does
Yes,
the
brother.
isolation mean?
Yes, brother. Yes, brother.
What does the isolations mean?
Brother,
Okay.
actually, I will show you one thing. If you go to hospital for checking our heart condition, you will see these type of things. Am I right?
Yeah.
So that means the distance between the two peaks gives you one complete wave.
Yes.
So likewise, it will be vibrating like this. How it will be vibrating? Clear?
Yeah. Okay.
So how
Yeah,
many times
yeah.
it will be? How many periods it will have? 919263177 Just imagine, it is unimaginable oscillation. A single atom, cesium atom, will give this much oscillation, and that will counted as in 1 second this many oscillation.
Okay. Yeah.
Clear?
Yes, clear.
Now, this derived units we already studied. If you want to find the answer for speed, we know the formula for speed, which is nothing but distance over time, and the unit for distance is meter, and the unit for time is second. So you will use the two fundamental quantities for getting the derived quantities. So the formula for the speed is from derived quantities, and also acceleration formula is nothing but change in time divided by time. Change in velocity divided by time gives you the unit of meter per change in time, because acceleration it will be like this: delta v over delta t. What is delta v? V2 minus
the V2 minus the V1, T2 minus
minus
T1.
T1, which
T2
gives you
minus T1.
T2 minus T1. This unit is meter per second, and the time unit is second. So what is the final unit? Meter per
Second square.
meter by
second square.
Clear. So likewise, the density. What is the formula for density? The formula for density rho, which is nothing but mass over volume. The unit for mass is kilogram. The unit for volume is meter cube. So the unit for density is nothing but kilogram per meter cube. Clear. So these are all the example for derived unit. Now, how to convert that unit? How to convert the unit? For example, you can see the box. Here I have meter, I have kilometer and meter. If you want to convert the kilometer to meter, what you have to do? You have to multiply by 1000. So if you want to convert meter to centimeter, just you multiply by 100. Suppose
100.
if you want to convert meter to kilometer, you can see the bottom. If you want to convert from meter to kilometer, you have to
Divide by 1000.
divide by 1000. Suppose if you want to convert from centimeter to meter, you have to divide by 100.
100.
So the small conversion will be given in your exam, so which carries 1 mark or 1.5 marks. Convert. For example, you can see at the bottom of the box, convert to 5 kilometer into meter. What you did? What convert 5 kilometer to meter? So what you have to do?
Multiply by
5 multiplied by 1000 gives you 5 kilometer in terms of meter. Clear? Likewise, 120 centimeter to meter. 120 centimeter to meter. That means you have to divide by 100. So 120 divided by 100 gives you 1.2 meter. Brother, some basic conversion will be there. You can just please recall this function all the time. What are the basic function? 1 centimeter, which is equal to 1 over 100 meter. 1 gram, which is equal to 1 over 1000 kilogram. So these are all the basic things. So you should remember all these things all the time. If the question will be very easy, if the question have the very easiest conversion, then you have to go by yourself. If the question have any difficult conversion, we will provide some hints. Understand? With the help of the hints, you have to solve. Clear, brother?
Clear.
Doctor,
Okay.
if I want
Yes,
to
brother.
convert millimeters into nanometer, what should I
Millimeter
multiply
converted
by?
to okay, nanometer. What is the value of nanometer? 10 to so in such a case, you have to go 10 to the power of -9.
Yes. Multiply
Clear?
by
So
10
first,
minus 9.
no. First, what you have to do? First, you have to convert that millimeter to meter. First, you convert 1 millimeter to meter. 1 millimeter to centimeter. How you convert it to 1 millimeter centimeter?
Divide by 1000.
So divide by 1000. If you divide by 1000, this is nothing but like this. Am I right? This becomes centimeter. Now 1 centimeter to meter. How you convert?
Divide by
Again divide by 100. Am I right?
Yeah.
Am I right or not? 1 millimeter. Sorry. This will be 10.
No.
This is not 100.
Yeah.
This is 10. Here it is 100. And after you converted the centimeter to meter, you know 1 nanometer, which is equal to 10 to the power of -9 meter. Clear? So first you have to convert the millimeter to centimeter, then centimeter to meter, then meter to nanometer.
Teacher,
For example, if I have 5 meters,
time's up.
and I want to convert it, I multiply it by 10 power minus 9, right?
Yes.
Okay.
If you have 5 meter, if you convert it to nanometer means, then you have to go for 10 to the power of -. That's what I told you to remember all these things. You can see in the table, here some informations are given in the table. You can see here. That's what we provide this information.
All of this are with the
No. Only these things: centimeter, millimeter, micrometer, nanometer, pico. Okay. Likewise here, giga, mega, kilo. This is enough.
I mean the meter, right?
Yes. Everything is because we are following MKS system. That's what we are using this. Clear? Okay, brother. I think the time is over for another class for you.
Okay. What about this session?
Okay. Inshallah. Today after my practice, because today afternoon I have a lab classes. After I finish my lab classes, I will open today's session 7 to 9. for discussing these 5 problems. Brother, listen carefully. Problems plays an important role in your theory topics, because most of the question is numerical type. Understand?
Yes, but I mean the session. Will you put it in the?
Yeah, I will open in the Blackboard today, inshallah.
Okay.
Yes.
Teacher.
Should we buy a book?
If you wish, you can buy. But that book is very good book.
Can you upload this live? Can you upload this live video?
Of course, brother. Listen carefully, brother. You are in my section. After I finish the lecture, generally I will upload the slides before a week. For example, next week we are going to study the 2nd chapter. What I will do during the weekend, I will upload your 2nd chapter. Understand? You just take a print, go through it. Inshallah, next week when I just come for chapter 2, I will ask you some question. Do you get my point?
Teacher,
Yes, brother.
the lecture recorded or not?
It is already recorded. You can get the information from the Blackboard.
Okay, thank you.
It's clear. But inshallah, today we have 7 to 9 session for discussing only this problem. If we finish this problem, inshallah, next week will be easy for us.
Okay.
Understand, brother?
Okay.
Yeah.
Have a nice day.
Okay. Thank you so much. Thank you so much.